So let's start. Oh my god, I can hear the door opening. Who's entering? But anyway, let's look at that. Wait, late students? Why are students late to my class? By the way, can somebody go to the office for me? I have not received my homework booklets yet. We're going to say 2 forces. Oh! So let's just hand them out. Can somebody hand them out, please?
Take classes here too. Would you like that?
Ruia College of the University of Mumbai.
Hello, class. Today we will be talking about the atwood machine. A machine that is kind of like an elevator because it has 2 weights. A weight which carries the elevator car where all the people are standing, and the counterweight which makes the elevator go up or down. It was invented by George Atwood in 1784 by an English physician. So anyway, the atwood machine is kind of like an elevator because these 2 weights are strung to a rope which is suspended by a pulley. So today we will be looking at if this kind of thing is a safe elevator. So by the way, you will only be using F equal M. Right, let's start. So we have drawn the diagram. We have finally finished the diagram. And so now what we're going to do is we're going to draw not just a diagram, but a force body diagram. Alright. So this diagram is going to look like, pulley. You have a rope. You have these 2 weights. And so, of course, we just take the 2 weights, we isolate them here. And these 2 weights, you have number 1. So number 1 would be mass number 1, which would be the weight, right? So, by the way, what is the mass of this thing? Well, that thing would be 9. Alright, so let's start. Oh my god, I can hear the door opening. Who's entering? But anyway, let's look at that. Wait, late students? Why are students late to my class? By the way, can somebody go to the office for me? I have not received my homework booklets yet. We're going to say 2 forces that are pulling on it. First of all, M1G, which is Fg. And then we have the rope tension, which would be Ft, acting on it from above. So that's that. And then the exact same thing's happening to F2. So, okay. Now we have drawn the full force body diagram. And now what we will do is we know that delta F or F is equal to MA. So sigma F, I think I screwed up the F there, is equal to MA. So anyway, that's true for both sides. Oh my god, more late students? Jesus Christ. But anyway, that is what that is. So now we know that sigma F equals to MA, but we know that sigma F, what is sigma F? Well, we know definitely that tension and Fg are both acting on it from our force body diagram. So we put that as all our forces there. So I guess that we can write that. And by the way, with the free body diagram, let's call it the force body diagram. I have a friggin' frog in my mouth. But anyway, we have F. Okay, so we have written the net force. Alright, so now we can continue on with this. So what we're going to do is, oh my god, I have a friggin' frog in my mouth. Force. But anyway, we have Ft minus Fg is equal to m. The thing is, acceleration is negative since Ft is actually less than Fg. Didn't you know that? So that means that acceleration is negative, so we will negate it for this part. And also, we will expand Fg and bring it to the other side, which gives us positive m1g on the other side. Alright, so we are making progress. So we will leave it at that for the first one, but for the second one, we also have to do everything for the second one. So we know that Fnet is not just 2a. By the way, why am I, oh yeah, I don't really like using sigma. Screwed me up the first time anyway. But anyway, let's look at what Fnet holds for us. So we know that Fnet, of course, is Ft again minus Fg. But this time, this means that Fg is actually less than Ft. So since Ft exerts more force, then that means that A is positive, and we are writing that second equation. Any thoughts? No. Alright, got it. So let's keep writing. And so that means that we have this equation. So we finally finished writing net force. Alright, so now we will move on to bringing Fg to the other side and then expanding it. Alright, so we will expand it. So Ft, move Fg to the other side, Fg plus M2a, and we have expanded it. Now we will put these two together in a cool looking system of equations. So you should know what a system of equation is, and now let's begin. Alright, so Ft is equal to mg plus m2a, and then we have, well, Ft is equal to, let's put the m2 on top, so that's what we're gonna put there. And we know that we want to solve for acceleration. So what we're going to do, we'll go through with the system of equations, see what it gives us, and then finally we will try and solve the acceleration from the remaining equation. So let's write down what we have over here. So that's our first equation done. Now let's write the other one on the bottom. And so m1 and then m1g minus m1a, and we have done the bottom. Now it's time to create the system of equations, and I think I screwed up the little underline, but let's just fix that one. And now let's add these. So we'll actually cancel out all of that stuff that we don't actually need, and now we get m1g. And then we actually that's minus m1g, sorry, and then plus m2g. So g is m1 minus m1 plus m2. So we did that, we factored out, and we also factor out on the other side, giving us this monstrosity. But now we will divide both sides by m1 plus m2, thereby isolating acceleration. So now we can finally peacefully solve for acceleration and plug it. Alright, we divide that by m1 plus m2, and we have almost got our answer. We can now peacefully solve for a. So we get a equal to g times m1 minus m2, actually, and then we divide m1 plus m2. So let's just look at that. So m1 plus m2, look at that. We have finally got the equation for our thing. And, oh my god, more late student. I did not expect this. Okay, let's just get the absent card. By the way, can somebody go to the office for me? I have not received my homework booklets yet. I really need someone to go to the office for me. Please? Thank you. Oh! I guess somebody already had the office booklets. So, let's just hand them out. Can somebody hand them out, please? Thank you. So, now, let's get back to our math. Alright, so what do we do here? Now, we have to plug in all our variables in that. Oh my god, no, my homework sheet! Okay, so the homework sheets have been dealt with. Now we are going to finish this. So that's equal to 9.8 times, 2, and then we divide that by, 9, 7, that's going to be equal to 16, and then now we'll just cancel them out and make it 8, so 9.8, finally, over 8, so there's somebody out there, somebody, have a...
What is it? It's 1.22.
1.22. For the answer, we've got 1.22. Now, I want to ask you one final question before I leave. Oh, oops, meter per second squared. Sorry for the unit. But anyway, I want to ask you one final question. Is this elevator safe to ride? And probably you would answer yes, because it's well below the limit of 2 meters per second and 2.5 meters per squared second. Second squared, actually. So, that is the answer to our Atwood machine problem. Thanks, everybody.
Soborno, who is known as the god of mathematics, became the youngest professor in the history of mankind. Hundreds.
To Bari Science Lab to fall in love with math and science, especially programming.